I start record this lecture already. So chapter 1 is just an introduction. It's not really, it's just a basic thing. So supposed to be you are not too heavy lah for your brain for the chapter 1. Okay, we continue with the chapter 1. I think last time we already until polymer. So all these engineering materials, type of engineering material will be covered later in chapter 5, 6, 7, 8 in detail. So last time you already see metal, and then you already see ceramic, and then today you will see polymer. So all this will be covered in detail in chapter 6, 7, 8, 9. Okay, each engineering material will have one chapter specific for that engineering material. But for chapter 1, we just go at a glance. We just give a brief introduction about what polymer, what metal, whatsoever. Okay, so the definition: polymeric material consists of organic long molecular chain or network. So it is a network. So it is actually one molecule, of one molecule of substance, and then it is a repeating unit of that molecule, and then it will become polymer. It is a repeating unit. For example, um, yeah, repeating unit like atom lah, atom and atom and atom, and then suddenly, and then finally it will become one big metal, or one big solid. Okay, the properties vary with strength. Oh, I think we already have. I think we already discovered. I think we already covered this chapter already. Yeah, also last time. Suddenly, it's like that I recall that we already covered this chapter as well. Yes, we already covered until here. I don't want to repeat because talking is very tiring. So I don't want to repeat. So you go back to my pre-recorded lecture later. I will figure out how to share that with you. Okay. This is the application of composite lah. So this one, this wall, the whole structure of this wall is made from composite. So it has a beam made from steel, but this wall all is made from composite. And then we have electronic materials or semiconductor, so capable to alter electric conductivity in just surface chemistry in very close areas. So it will behave in between of conductive and non-conductive. The conductivity is as good as metal because no free electron and electron valence is full. This is the strength. This is strength, various categories of material. So first we have first category, which is polymer, and then second category, third, fourth. So the strength in PSI, so polymer is the lowest lah, the lowest value, and then ceramic, the second one, and then composite and metal and alloy. But this one is not the strength to weight ratio. This is only strength. This is only strength, not strength to weight ratio. So if strength to weight ratio, probably ceramics will be higher than metal. So what is the meaning of strength to weight ratio? Strength to weight ratio is the strength divided with the density of that material. For example, you can say that for example, you cannot say. I give you an easy example lah. You can compare wood with steel. So you have one wood and then you have second steel. So which one is stronger? Which one is stronger? So you may think that the stronger material is steel. Okay, steel is stronger. But in order to make a fair comparison, you have to divide this the strength of the steel with the density of this steel, and this wood, the strength of this wood with the density of this wood. So you will get one value in which this value is known as strength to weight ratio. So which value is higher will be known as a stronger material. Faham tak?
Faham betul.
So if you don't really understand, let's say you can say that a 5 years old boy with 35 years old adult man. Okay, you cannot say that this 35 years old adult man is stronger than this 5-year-old boy. Okay, in order to make a fair comparison, you have to divide the weight of this boy and then the strength of this 35 years old guy with his weight, and then you will get one value, and then this one can compare with this. So that is why if you are watching an Olympic game, Olympic sport, um, weightlifting, do you know weightlifting weightlifting sport? Weightlifting sport is suka angkat berat. So this weightlifting sport is divided into several categories, in which that the category is based on the weight of the participant. So perhaps below 50 kilogram, between 50 to 70 kilograms, something like that, and then over 80 kilogram. So this is how the division of this sport is made, because this weight will provide a certain amount of momentum. So you cannot compare. You cannot compare a 5 years old boy with an adult man, because that is an unfair comparison. Faham tak? So similar to wood and steel just now, okay? So my point is, this one is only strength. This one is not a strength to weight ratio. So if strength to weight ratio, probably ceramic will be stronger than metal. Ceramic will be stronger than metal and alloy. I think this one also we have seen last week. Yeah, I show you the YouTube already. Smart material. Smart material is the material when that is capable to react with the environment. For example, shape member alloy, chromoactive material.
Hello everyone, today I will talk about smart material. Smart material are material that are manipulated to respond in a controllable and reversible way, modifying some of their property as a result of external stimuli, such as certain mechanical stress or certain temperature, among others. Because of their response, the body cool down, about building that adapt or relate into the bloodstream as soon as a viral infection is detected. Smart material can be divided into 5 types. For the first one is piezoelectric material, shape memory material, chromoactive material, photoactive material.
The chromoactive material is the example is like this cup lah. Cup, the original color is black, but when you pour a hot water into the cup will change the color into white. So that is chromoactive material. Okay, shape memory alloy is the alloy that will return to its original shape when you give heat, when you give to it. Okay, that is several example lah. I think I show you already um, last week. This is what? Shape memory alloy. Shape memory alloy is alloy that can return to its original shape when subjected to heat. And this is chromoactive material. Okay, this is just an example lah. And then there are other things which is included as smart material. And then we have photoelectric material. So when you expose this photoactive material, it will produce a reflection of light. It's like a rear reflector of your. For example, you drive a car, and then there is a car in front of you. So when you give high beam to that car in front of you, so the rear of the car will give a reflection. We give a reflection as if that it has light, but it is not light. It is because the properties of that material will give a reflection of light when it is subjected to light. Faham tak? Faham tak bahasa Inggeris saya? Do you understand my English? Or you prefer me to speak in Malay? I'm just afraid that we have an international student in our class. So that's why I speak in English. Okay, it's open. It's open to suggestion. No, Aiko. You can ask me what I need to do. Okay, you tell me what I need to do.
So far, so good.
Okay, thank you. And then recently there are a few other smart material which has been discovered, and the one that attract my attention is graphene lah. So graphene is a new material discovered in 2004. So it is a one layer atom material. It is a very outstanding.
Doctor, I have one question about the graphene, doctor.
Yes.
Is it true that let's say that right now our phone is using the what they call that lithium ion, right?
Mm-hmm.
So they try to convert the lithium ion using the graphene. Is it true that the graphene is not combustible?
It's not what?
It's not combustible. Senang terbakar.
Graphene actually is carbon. The easiest example that I can give for material made by graphene is pencil lead. You know, pencil lead, mata pencil. So if actually graphene is combustible because it is carbon. Okay, if you Google graphene is carbon. Okay, graphene is carbon atom. So that is why graphene appear in black color because it is carbon. So it is combustible. The reason why graphene can be the suitable candidate to make battery, like to replace the lithium ion, is because they discover that graphene is high capacitance. It can restore lots of energy in graphene. So that is why, and then it's also conductive. So that is why it has the potential to be used as a battery lah. Jawab soalan tak?
Jawab doktor. Sumpah jawab.
Okay, good question. So if you have any question, just ask.
But so far, the technology is quite new or still far away, doctor?
The technology,
In terms of converting the graphene to battery, like storage battery.
actually, researchers are still researching how to produce graphene in one layer atom in a high scale, to make a mass production, because to obtain the one layer graphene is very difficult. So in order to realize the application of graphene to convert to make something, they have first to synthesize how to get a one monolayer graphene. So actually, the research is still at that area because we cannot really get one monolayer graphene. Faham tak? So how can you extract one layer atom? One layer atom is very small, so that's why it is a challenge. Okay, so graphene properties. So first, it has high thermal and high electrical conductivity, and then it is light, flexible, up to 200 times stronger than steel. It has been tested, and then it was known to be having strength 200 times stronger than steel. And then low vulnerability to overheating. Low vulnerability means it is combustible, but it is not going to flame. Okay? Dia tak terbakar, tapi dia boleh terbakar, but it is not, when it is subjected to direct fire, then it will burn lah. It will burn. But if you just put in an oven, it will not burn. Then it has molecular capacity for self-repair and then other things lah. This is the material selection process to make something. So if you want to make a product, or you want to design something, this is how you need to do in order to choose the right material. First, you have to know what application that you want to use that product for. Application mean the penggunaan lah. Application, that is application. Application means awak nak guna benda tu kat mana. That is the meaning of application. Faham tak? Okay, application is awak nak guna benda tu kat mana. So once you know the application, you can determine the required properties. For example, you want to make a fishing rod, for example. Fishing rod is apa namanya fishing rod in Malay? Batang pancing. Okay? So you have to make a fishing rod. So the application, this is the application. Application is fishing rod. Okay, this is the application. So from the application, you can determine the required properties. So fishing rod must be high strength, low weight, flexible. Flexible means boleh lentur. Okay, flexible means boleh lentur. So it must be high strength, because if you catch a very big fish, that fishing rod must have the capability to not to break. Okay, and then low weight, because low weight is required so that it will not be too heavy for you to carry. Okay, and then must be flexible, because when you catch the flexibility of the fishing rod will have the higher chances that you will be able to bring the fish um, to the shore lah. Okay, because if it is not flexible, it does not like a spring, it does not have a spring behavior. The fish will shock. Faham tak? Dia akan macam terlalu keras. Tak ada kejut, tak ada apa, tak ada buayan, tak ada lenturan. No flexibility, so it is not that desirable. If you want to make a fishing rod, the fishing rod must be flexible. Okay, so these are the required properties. These are the application. Faham tak? And then from the required properties that you have determined, you can identify the candidate. So what types of material that can be used to make fishing rod? Can you make the fishing rod using glass, for example? Glass or ceramic or clay? Okay, kaca, ceramic or tanah liat. Can you make fishing rod using this? Definitely cannot. Okay, because this is very brittle. So you have to find another candidate lah. So maybe you use metal, composite or whatever, and then after that you will evaluate which one is the best material lah. And then from the material that you have determined, for example, you want to make this using a metal alloy. So you have determined that the material should be made from a metal alloy. So how to process this metal alloy? This is how you identify. Okay, first you have to make mold, and then you pour the metal alloy into a furnace, and then heat maybe around to 4,000 degrees Celsius until it melts. When it is melt, pour into mold, then it will become the fishing rod. That is just an example. This is tutorial. You can try yourself if you want. Look at it if you like to see it. But normally I don't answer this tutorial in the lecture, because you can just answer yourself, define material science and engineering, what are the main classes of engineering material. Okay, so already 3 o'clock. I think better I'll take some rest. Before we go to chapter 2. So now 3 o'clock, 3:15, 3:15 you come back. Okay, we can continue with chapter 2. Chapter 2 is about material structure and bonding. So what is atom? So atom is structure that have nucleus, which is proton and neutron, and also electron lah. So it has nucleus plus proton. So this is atom. So this is an example lah. Example, so nucleus has electron, proton, and neutron. This is proton, this is neutron. So valence electron. So valence electron is the outermost field shell. So electron yang paling luar, outermost. I think you have studied this in form 4, form 5, I think. In matriculation also you have studied this. So it is just a recall, okay? A recall, a refresh from the previous chapter of your life. Okay, so this valence electron, the outermost field shell, and this electron are extremely important as they participate in the bonding between atoms. So they participate, the valence electron will participate in the bonding of atom, and this participation of the valence electron will determine the electrical, mechanical, chemical, and thermal properties. Okay, so this bonding will actually determine these properties: thermal, mechanical, chemical, electrical. Okay, example is carbon. Carbon has 6 atom number. 6 atom number. So the rule is 2, 4. So you have 4 valence electron. Four valence electron. And these 4 can be detailed into 2s2 and 2p2. Types of bonding, you have 3 types of bonding: ionic, covalent, metallic. So ionic is transfer electron. Covalent is sharing electron. Metallic is electron can flow throughout the whole structure without actually, as if it is not attached to any particular atom. Okay, so we look at ionic bonding first. Ionic bonding so occur between positive charge and negative charge ion. So it requires electron transfer. The example is natrium and chlorine, chlorida. This is natrium. This is Cl. This is non-metal. This is metal. So natrium has 1 positive charge. So it will transfer electron to Cl in order to achieve stability. Okay. In order to achieve stability, so this natrium will transfer the electron to Cl in order to react. Okay, so it will make this element and this element combine, becoming lithium chloride. So this is an example of ionic bonding. So typically it involves between metallic and non-metallic elements. Okay, typically, a the material that has the bonding with ionic bonding, they are hard, good insulator, brittle, high melting point, and some are transparent. So this one you need to. There is no way that you can understand this slide. I think maybe you need to memorize it a bit, unless if you can um, imagine this transparent could be like perspex per spec. So this is a material which is transparent like plastic. And then covalent bonding, you have sharing electron, and this sharing electron typically occur for the material, for the element which has similar electronegativity. Similar electronegativity means it is from the same side of the periodic table. It is from the similar amount of electron valence. Okay. For example, CH4. Okay, CH4, carbon and hydrogen. Carbon has 4 electron valence. Hydrogen has 1 electron valence. So because the difference is not that far in terms of the electron valence, so that is what we call as similar electronegativity. Similar electronegativity means um, the difference between electron valence is not that huge. It's not like 1 and 8. It's like 1 and 2 or 1 and 3 and 1 and 4. So this is similar electronegativity. Okay. If 1 and 8 or 1 and 7, 1 and 6, this is not similar. Okay. So bond determined by valence s and p orbital dominate bonding. Example CH4. So we require H atom, 4H atom, 1, 2, 3, 4. So it has 1 electron valence, and it will share with 1 electron valence from carbon. So to make it 8, so 8 will be stable atom. And then metallic bonding occurs in solid and metal alloy. In solid state, atoms are packed relatively close together in a schematic pattern or crystal structure. The valence electron of metallic material are not bound to any particular in solid and more relatively throughout the entire metal. The electron belongs to the metal as a whole, or forming a sea of electrons. Okay, so metallic bonding is a bonding which occur for metal and alloy. Okay, when metal is formed from a liquid to solid, so it will undergo cooling. Okay, for example, from 4,000 degrees Celsius, in order to become solid, we take out the heat, and then it will become solid at 25 degrees Celsius, or this is a room temperature. Okay, RT is room temperature. So when during the solidification, when it transforms from liquid to solid, atoms of this alloy will be packed close together. in a systematic pattern of crystal structure. So the atom will arrange themselves in order to be in a systematic manner or systematic pattern, or we call it a crystal structure. So if atom is well arranged, we call it crystal. If atom is not well arranged, or we call it random arrangement, we call it non-crystal or amorphous Okay, amorphous. You already see this in chapter 1 already. Actually, I show you, but we will go into detail. I think maybe in chapter 3. So I repeat, when atom was arranged or is arranged in a well-ordered manner, the arrangement is called as crystalline or crystal structure. If the arrangement of the atom is not well ordered or in random pattern, it is called as amorphous or non-crystal. Okay, so when the atoms is arranged in a well ordered like this, okay, so there is electron outside each of the atom. There is electron. Okay, electron outside each of the atom. So these electrons are not bound to any particular atom in the solid and are more or less free to drift throughout the entire matter. So this electron valence for each atom actually can move freely anywhere. So that is why it is called a sea of electron, forming a sea of electron. Okay, so illustratively, it can be seen like this. So this small dot is electron. This is nucleus. So this atom or this nucleus is arranged, well ordered or organized, and then the valence electron move freely throughout the whole structure. So that's why it can be seen as a sea of electron. So this is the reason why metal is electrically conductive, because the electron is very free to move around the structure. Okay, the outer electron easily move around as they do not belong to any one atom, but part of a whole metal crystal. Faham tak?
Faham betul.
Faham betul.
Okay. The remaining non-valent electron and atomic nuclei from iron core, which possess a net positive charge equal in magnitude to the valent electron charge per atom. And atomic nuclei from iron core, which possess a net positive charge. Example is also non-directional. Metallic bonding may be strong or weak. The properties of metallic bonding are so metallic bonding has good ductility. For example, aluminium or metal or other metal, it can be bent. Can be bent, that means it is ductile. If it cannot be bent, for example, glass, you try to bend glass, it will break. So this is called brittle. But metal is ductile because it can be bent. And then good electrical conductivity. Good electrical conductivity because of the sea of electron. Okay. And then lustrous and malleable. Okay, I think Actually, I'm not well today. I'm not feeling really well. I think maybe I finish the lecture now. We continue probably on Thursday live. So I see you on Thursday at 4 o'clock.
Thank you, doctor.
Okay, have a good day.